Hi, I'm Anja Mirenska, data scientist at Cellkraftwerk. Today I'd like to show you how to analyze data from CellScanner with a Cell Explorer software. The sample that I'd like to analyze with you are PBMCs from a healthy donor. The aim of this experiment was to provide a deep phenotyping of the sample. Cells were stained with 37 different biomarkers. As you can see on the screen, the cells have been recognized by the software. These are the circles that you can see on this picture. Let's proceed with the actual analysis of the fluorescence values. Let's first plot CD4 versus CD8 and create a gate for CD4 positive T cells. Let's give it a nice color. And now let's look further into it. For example, by plotting CD39 and CD25. Where we see that these would be the Tregs and these would be the activated CD4 T cells. Let's look at the deep phenotyping of the PDCs, which are more difficult to phenotype. For this purpose, I'll plot CD123 and MHC2. Now PDCs would be CD123 positive and they would also be MHC2 positive. So it would be this population probably, but we can phenotype it further. However, there might be still some monocytes or macrophages within this population, so let's exclude them. Let's plot CD14 and CD11b. Let's show only our CD123 positive MHC2 positive cells. And let's gate on these ones, which now really should be the PDCs. Let's give it a bright color. We can now further look at some markers, for example CD45RA and CD38. I'll compare those, the expression of these markers by the PDCs with expression by all the cells. So you see that how I set the gates. Now again, let's look only in the PDCs and we see that they are both positive for CD45RA and for CD38. Now what's about, let's say, CD45? Oh, that's cool, they are CD45 negative. Let's now have a look at those cells on the original images. Let's look at the CD123. Which is this one. And here you can clearly see the cells that we have selected. You can browse through the images. Let's take, for example, this cell here. You see it's clearly CD123 positive, CD11b negative, as we said, MHC2 positive, CD27 negative, and so on and so on. So in case you got any results that you're not sure about, if it's an artifact or not, you can always go back to the original images and have a look at your gated populations on these original images. Now, if 37 biomarkers are not enough for you, you could analyze as many more markers as you want on the same chip. You could also put your chip into the biobank, wait for, let's say, a year, and stain the next marker after that year. If you don't want to stain your additional biomarkers one by one, you can also design new multicolor cocktails. When doing this, you don't need to worry about spillover, because the detection channels are designed in such a way that almost no spillover takes place, so there is also no need for compensation. This means that developing a multicolor cocktail for Chipcytometry is much faster than for flow cytometry. You just need to find the right clones with the right colors, mix them together and put them onto the chip. Also, if you'd like to switch from Cell Explorer software to your favorite flow software, for example FlowJo, you can easily export all the fluorescence values as a CS file from the Cell Explorer and use it with your favorite software. I hope this short introduction was useful for you. Thank you very much for your attention.